we're going to talk about how you actually compute the correlation coefficient. So we'll do it by hand this one time, and then, I'm loosely using the words by hand because in reality, we're still going to use the calculator to support our work, because finding the mean and standard deviation, even of a simple data set, is not the easiest thing in the world to do. Mechanically, conceptually, it's not difficult, but mechanically, it's a pain. All right, so let me get my calculator out. All right, so we're going to type all this data into L1 and L2. We'll use the stat calc function to check our work when we're done, but for now we're just going to do it using the table. All right, so stat edit. Let me clear out my columns. So 0, 3, 21, 1 to 15, 30. All right, so once you have your data in, we need the mean and standard deviation for both data sets. So stat, calc, 1. And we're just going to do list 1 and 2 separately. You could actually do, check that. I'll show you a different way to do it. Stat, calc, 2. 2 variable statistics, L1 and L2. All right. This will crank it out all in one shot, right? At first glance, it doesn't seem like it did, but you just scroll down, yeah. So we're looking at 17.4. And 20.473-ish. 2.9. Yeah. Oh, this is weird. Oh, there it is. My app is misbehaving a little bit. 2.0248. All right, so we got all that information, which is great. Let's get that in there. All right, so we got all that information. Now what we have to do is find the z-score for every one of these data points. Yeah, sounds like fun, right? But it's actually super easy. Barely an inconvenience. So stat, edit. So we're kind of at that point where you're like, couldn't we just use the calculator technique? Well, yes and no. The idea here is that we're going to be able to use the calculator shortcut, but in theory, this is showing you where that shortcut is coming from, number one. And number two, it's also giving you a feel for the mechanics of it, all right? Because what we're doing when we're finding z-scores is we're finding how far, or the deviation for each x value from the mean for that particular data value, all right? So, or data set, all right? So theoretically, what we're going to say here is that you have some line, you have the point on the line, and then you have the point in space. Let me put it somewhere else, a little bit off, a little offside. All right, so what's going to happen is we're going to create a rectangle containing both of these points. All right, that rectangle is going to have a horizontal deviation and a vertical deviation. So it's going to have a z-score in y, and it's going to have a z-score in x. This area is the product of the two. What this process does, this process minimizes that area, right? It gives us a sum of those areas, but on a minimum level, all right? So if we minimize the squares, essentially if you minimize a rectangle down to its instantaneous changes in y and x, then it's approaching a square, all right? So that's becoming what they call the least squares, all right? So because there's more than one of them, there's 10 of them. 10 of those squares, we're coming up with the least of those 10 squares, right, in terms of the area. So that's why they call it the least squares regression, all right? But in order to do that, we'd have to find each of these deviations, the z-scores, and then find their products.
Sorry, what do those 2 points represent? The one on the line and the one on the
The one on the line is the point on the line that is consistent with that particular data point, like where it ought to be, if it were on the model itself. This point in space is the actual point. All right. So what we're going to do is use a calculator to do all this work for us. So in my L3, I'm going to have it run this computation because all of my x values are in L1. All my y values are in L2. So in L3, I'm going to have it compute x minus x bar over s. All right, so I'm going to do, in parentheses, L1 minus x bar. All right, so you're going to go into your vars menu. You're going to select, I believe for you it's option 5, statistics. And then you're going to choose the one that says x bar. Then you're going to go back into, and so divide. Then you're going to go back into that vars menu, vars, option 5, statistics, and choose SX. All right, and then hit enter, and it's going to compute all of those z-scores for you simultaneously. So instead of doing those computations yourself, you know, you still got to write it down, but at least you don't have to figure them all out individually. All right. So, and you can put the approximate values in here because the calculator is storing in the more exact values, right? So you could just rough it out. About negative 0.85, negative 0.70, negative 0.118, or positive 0.18, negative 0.12. These are really just placeholders, bless you. These are really just placeholders, so we're not really worried about rounding instructions and stuff like that. At least not for this. Negative 0.61. Okay, so I screwed all of that up because I started at the wrong place, it looks like. Hey, what? Well, hold on a second. No, that's good. Oh, I think I just skipped too much. All right, so 1.10, 2.08, and a couple of negative 0.85s. All right, so we're going to do the same thing for L4, except we're going to call upon L2 and the Y stuff. All right, so L2 minus vars statistics Y1 divided by vars statistics SY. Let it run the numbers, and then all you have to do is just write it down. So we're talking negative 0.94, negative 0.44, positive 0.54, 0.05, 1.04, negative 0.94, 1.53, data analysis is fun. I must have missed one.
I think you missed 1.04 between negative 0.94 and 1.53.
Oh. Gotcha. All right, and so in L5, we're just going to multiply those two entries. All right, so that was in L3 and L4.
To what extent do we need to focus on rounding here?
Same as the previous columns. So all you're going to worry about is the final answer in terms of rounding. All right, so we're doing L3 times L4. That's one big multiplication symbol. And we're going to write all that. Oh, it shouldn't be negative. Why did I put a negative? So that was fun. So now we got to add all that up. But we're not really going to add it all up.
How are we going to do it?
We're going to use the sum function in our calculators. So second stat, math 5. All that information was stored into L5. So we're going to find the sum of L5. Which is about 8.332. Again, still not overly concerned with rounding. All right, what we got here was all of this. Now we just got to multiply it by 1 over n minus 1. All right, so we're finding really product of deviations. All right, but it's on the sample level, so thinking back to a sample standard deviation formula, we always divide it by 1 over n minus 1. All right, it's a correction factor based on something called the degrees of freedom, which we're going to get to in the next unit. So we're getting closer and closer to fully understanding why that is the way it is. But there are 10 data points, so we're going to multiply. No
I
problem.
have to get my compasses.
Your compi.
My compi.
So you're going to multiply by 1 over 9. So same thing as dividing by 9. All right. So 0.926. 3 significant is what we do, but only for the final answer. All right. Now, we could graph this data set, but just by looking at the numbers, it does appear, and also we talked about this before, the context